Hi, let's solve the second question from today's weekly contest, that is maximize happiness of selected children. So in this question, you are simply given an array, happiness of length n and a positive integer k, right? So two parameters, happiness, array and an integer k. Now there are n children standing in a queue where the ith child has happiness value of happiness of I. Okay, so basically we are representing these as happiness value of different children, right? So these are how many children? Three children, and for three children the happiness values are given. So this child is happy by 1 units, this child is happy by 2 units, this child is more happy, that is by 3 units. Now you want to select k children from these n children in k turns. Now this k basically represents how many children you have to select out of the children given inside of the happiness array. So in total you are given 3 children and you have to select 2 children. Now, in each turn, when you select a child, the happiness value of all the children that have not been selected till now decreases by 1. Alright. Now, what we are being told is, let's say we have this array, okay? So these are 4 children standing. So let's say here is a teacher, right? And there is some children standing here. So let's say this is child 1 with happiness value 2. This is child 2 with happiness value 3. This is child 4 with happiness value 4. And this is child 4 with happiness value 5, right? So let me denote it by H, H2, H3, H4, and this is first, second, third, fourth child. So this is the scenario. Now you are being told that you will have some turns, right? So turn basically means that this child comes here, okay? So in each turn, what will happen is when this child is having his turn, right? The happiness value of these children will decrease, right? It's just that they're tired of standing in a queue, right? So they're just their happiness value is decreasing by 1, right? So let's say, okay, so let's say he's having his turn, right? This child, if he's having this his turn, so when we will go for the second turn, right? So their happiness value would have become 2. This will h2, h3, h4. Now let's say I pick up this child, so their happiness value will reduce, so it will become h2, h3. All right, so let's say ck is 3, so we have to see how many turns we have. 3 turns, so I have to select the third child, so he has happiness, so his happiness value will decrease by 2. Now I had to only do up to k turns, so that's complete. So that is what's being written in the question. Now they have also told you that if happiness value cannot become, see, happiness value cannot become negative, it only gets decremented if it is positive, which basically means only a positive happiness value will get decremented. Now you need to return the maximum sum of the happiness value of the selected children you can achieve by selecting k children. All right, so basically you can decide which child you have to select, and what you need to do is you need to maximize the happiness. So you can say this teacher is trying to get some happiness out of the children, and this teacher wants to become most happy, so he will try to choose children with more happiness, right? So as to maximize his happiness, right? So this is what you have to do in the question, maximize the teacher's happiness. So let us see how we're going to do it. Now let me erase this, let me write this normally again. So this has a happiness of 2, 3, 4, oh sorry, 4 and 5. Now what you have to do is maximize this teacher's happiness. So in each turn what's happening is the happiness is getting reduced by 1, so you'll try to take the maximum happiness first. So this kid is the most happy, so this teacher is, he's greedy, he'll take this kid. So now the happiness of the teacher has become 5, but by this turn the happiness of these children will get reduced by 1 each, right? So it will get 1, it will get 2, and it will become 3. Now the teacher again, he wants to maximize happiness, he's gonna choose which child which has the most happiness, right? Who's the most happy, and which child is the most happy here? This one, right? With happiness in with 3, right? So then the teacher will say, I will select this kid now. So your happiness now will become 5 plus 3, that is 8. All right. But again, after each turn, the happiness reduces by 1. So for him, the happiness has become 0. And for him, the happiness has become 1. Now the teacher would be like, okay, his happiness is already 0. He has the max happiness. So I'll pick this kid up. So he'll say 8 plus 1, it's 9. And after picking this kid, all 3 turns are completed, and now the teacher has become the most happy he could have in this particular scenario given the children and their happiness indexes, right? So what we have to return is the maximum happiness that this teacher is going to get. So in this case it's 9, right? Let's say what let's take a case when we the teacher would have randomly just taken kids, and would he get the maximum happiness? Let's see. So let's say he takes this one, right? So let me draw it here. Let's say we just go line by line, right? So this is h2, h3, h4, h5. Now the teacher chooses this kid, so their happiness, so teacher has happiness of 2. Now their happiness gets reduced by 1. So we'll have something like this. Then the teacher, let's say, chooses this one, this kid in the next turn, so his happiness becomes 4, and these happiness decreases by 1 each. Now the teacher chooses this person, this kid with happiness 2, so the teacher's happiness becomes 6. So now you can see that not in every scenario you're going to get the maximum, right? Even though the you might say that, see, in every case the happiness is getting reduced by 1, so we might choose any indexes and will be fine, but actually not. And you can see using this example, right? So basically what you have to keep doing is you have to keep selecting the maximum happiness kid, right? And or the maximum happiness for the teacher to become the most happy, right? So first of all, let's I hope you have like understood the question what it is, right? So this is a teacher and these are some children, and he wants to maximize his happiness by taking some children in k turns, only k children in he turns in. And by each turn, the happiness of the other kids who are not being selected or whose turn has not come decrements by 1. All right. So that's the question. Now let us see how to solve the question. So you are able to see here that we are just being greedy. Each time what we want is we want to select the kid with maximum happiness. Right. So when we try to think of this, like, we want to select the kid with the maximum happiness. So either you will try to sort the array, or I will tell you a better approach, that either you can use a priority queue or a min heap, right? Because in each time you have to keep selecting the kid with most happiness, right? So both of the solution may work. So I'm going to go with this solution, that is, sorry, not min heap, max heap here you'll have to take, because you want to take the maximum happiness first. So all right, so what you'll do is you'll make a priority queue. So inside of your priority queue you'll be storing values like this. Now what you'll do is each time you have to pick an element, you'll pick the top element of the priority queue. Now there is also another thing that is happening here, is that in each turn your happiness is getting decreased by 1, right? So here when I'll have to select this, I have to keep track of how much my happiness has reduced. So for that I'll take a variable, let's call it d for now. So this d will initially be 0 for this person, right? And after that, with each iteration, this d will become 0, right? So what we'll try to do is, first of all, we created this priority queue, then we'll be iterating in the priority queue, and we'll also be keeping a track of the number of turns done, because the happiness is going to reduce for the rest of the children by the number of turns that have been done, right? So first what I'll do, so let's take answer variable, and here I'll store 5 first, right? So 5 minus d basically. Then after this iteration, I'll do d plus plus, which means I have basically done 1 turn. And then while choosing the next greater element, which is 4, right? I have to add 4 minus 1 to my answer. And this I have to do while k minus minus, that is I have to keep reducing this k. And you can also have a check that priority queue must not be empty, right? But in this question it's already like you will get an answer, right? So you don't have to really worry about your priority queue getting empty or not, right? So there is basically no case in this question where you would not get the maximum happiness value. So you will definitely, right? And there is no case where the happiness boils down to zero. All right. So, oh sorry, the this can become zero. The happiness can become zero. It's basically you will not run out of children. So k is always less than the number of happiness values you have. All right. Now, what you have to do is go here, right? So after adding this, you have 5, right? Then add 4 minus 1 to it. You'll get 8. Then come to here. Also do d plus plus. So in the third iteration, your d will become 2. So now you have to add what? 3 minus 2, which is 1. So this is what your answer will look like. So I hope you've kind of understood the question and what we will do in the code. Let me show you the code, it will be more clear to you. See, what we are doing is we have declared the priority queue, right? So this is the syntax to declare a max priority queue. Now we have also declared an answer variable, and here we are just making our priority queue. After we make our priority queue, we are also declaring d, which is basically the number of turns that we are going to have. Initially it's 0, and then we are iterating here while k, right? So yeah, so this is basically while k is greater than 0, right? Then you have to take the top element. So this is the child happiness, right? This is the maximum child happiness that you're going to get from the top element of the priority queue. Then simply pop this element and do minus equal to d to it, right? And also increase the number of turns. Then simply check if this happiness is greater than 0, right? Greater than equal to 0, only then you have to add it. Otherwise, obviously you cannot add a negative value that has already been mentioned, right? The values will not get negative, right? They can become 0 but not less than that, definitely. Okay, so then you'll add that particular happiness inside of your answer, basically child happiness minus the number of turns that you had, and simply do k minus minus. And after this iteration you would have selected k children to maximize the happiness of the teacher, which is stored inside of the answer variable, and which you have to return also. So we'll simply return answer. So I hope you have kind of understood what we had to do in this question, right? Now let's discuss about the time and space complexity. So the time complexity for this question, you can already see we are using priority queue. So to make the priority queue, it's this operation, push operation, takes log n of time, right? Let's say n is the number of elements we have. So you are iterating in the array and also you are pushing the elements in the priority queue. So this takes n log n time basically. And here you're simply iterating in the priority queue, so which isn't a lot. It's going to be, in the worst case, big O of n only. So yeah, so the total time complexity will be big O of n log n. Let me write here also. Time complexity is big O of n log n. And space complexity, you can see we are using a priority queue. So in the worst case, we can have n number of elements, so which is, this makes the space complexity big O of n. So I hope the question is clear to you. So that's it. That's about the question.